In this video, we are continuing with paper 1 revision, and we're working on equations with exponents, and we will handle the following 6 examples. In our first example, we have 3 to the power of x plus 3 minus 3 to the power of x plus 2 equals to 486. And what I can see is that we are focusing on the same base of 3 to the power of different exponents. And what we want to do is we want to find a way to simplify or solve x. And if you can remember, in grade 8 and 9, you learned the laws of exponents. And the first law that you learned was when the bases are the same and we have different exponents and we multiply these two terms with each other, then we add up the exponents. Now in this example, we can see the exponents are already added up, so I can reverse that law. So I can rewrite 3 to the power of x plus 3 as 3 to the power of x times 3 to the power of 3. And I can do the same with the second term. It will be 3 to the power of x times 3 to the power of 2. And that is equals to 486. Now the reason why we want to do that is to create a common term, a highest common factor, so that we can factorize. So I can see here 3 to the power of x is a common factor, so I factorize by taking out the highest common factor, and that is equals to 486. Now you could have taken out 3 square as well, but for now we're going to keep it in the bracket so that we can find a numerical value here. So this would be 27 minus 9. 3 to the power of 3 is 27, minus 3 to the power of 2, that is 9. And 27 minus 9 is equal to 18. Now, if I divide by 18 on both sides, on the left and on the right, I would see that the 18th on the left will cancel out, so I'm left with 3 to the power of x. And 486 divided by 18 is equals to 27. And I can rewrite 27 as 3 to the power of 3. Therefore, x is equal to 3. You can see that the bases are the same, and therefore x becomes 3. In our next example, we have 2 to the power of 2x plus 1 equal to 3 minus 5 times 2 to the power of x. Now if you look carefully, we can see we have different types of exponents. We have 2x on the left hand side and an exponent of x on the right hand side. So our previous method of factorizing or taking out the highest common factor will not work. But what we can do is follow the same procedure of splitting the left hand side up. So that becomes 2 to the power of 2x times 2 to the power of 1 equals to 3 minus 5 times 2 to the power of x. Now if you are comfortable, you can rewrite this in standard form and factorize. But if you are not, you can say let k be equals to 2 to the power of x. So I take the simplest 2 to the power of x and I make k that. So I'm not using 2 to the power of 2x. Then I would have in the first term, it will be k squared times 2 to the power of 1 equals to 3 minus 5 times k. And if I rewrite that in standard form, it will be 2k squared plus 5k minus 3 equal to 0. So I bring over the negative 5 becomes plus 5, and the positive 3 becomes negative 3. Now that it is equal to 0, I can solve k. And I can do it by factorizing. So it will be 2k in the first bracket and k in the second. 3 and 1. And it will be k plus 3 and 2k minus 1. And in one of our previous videos, we spoke about testing the middle term. Now I can solve for k, so k is equals to negative 3, or k is equals to a half. Now remember, we replaced 2 to the power of x with k, so I can substitute 2 to the power of x back in. So 2 to the power of x is equal to negative 3, and that is impossible. And then here we have 2 to the power of x equals to 1/2. And I can rewrite a half as 2 to the power of negative 1. And now that the bases are the same, I can see that x is equals to negative 1. And the reason why this becomes impossible, because the base is not a 2. Our next example is a little bit harder. We have 5 and cube root of x minus 80 times x equal to 0. The first thing I can do is get rid of the root, and you would have learned that you can rewrite it as x to the power of 1/3. Now I can see with minus 80x, x is to the power of 1, but 1 can be rewritten as 3/3. And I can take out a highest common factor of 5 and x to the power of 1/3. And if I factorize, in the first term I'm left with a placeholder of 1. And in the second term, if I take out 5, it's 80 divided by 5, which is 16. And then x to the power of 2/3, because I've taken out or factorized 1/3. And that is equal to 0. So I simply took out the highest common factor. Now I can set 5 x to the power of 1/3 equal to 0 to solve x, or I could set the bracket equal to 0. That is 1 minus 16x to the power of 2/3 equal to 0. And here it is simple to see that x would be equal to 0. Regardless of the manipulation, it will become x equal to 0. But here on the right, I have a little bit of work to do. So it will be 1 equals to 16x to the power of 2/3. So I simply took over the 16. Then I can divide both sides by 16. So it's 1/16 is equals to x to the power of 2/3. And I can rewrite 16 as 2 to the power of negative 4. And in order to remove the 2/3 in the exponent, I multiply by its reciprocal. So that is 3/2. And what I do on the right hand side, I would do on the left as well. So therefore I have x is equals to, now it will become 2 to the power of negative 4 times 3, which is negative 12 divided by 2, so that's negative 6. So it's 2 to the power of negative 6. And if you want to simplify, you can see that x is equal to 1/64. In our next example, we have 2 to the power of x equals to negative 1/2. So I can remove the half over. And then I can rewrite a half as 2 to the power of negative 1. Therefore, x is equal to negative 1.